Hi everyone, I am Praanshu and I have approximately 3 years of experience working as a technical project manager. Currently, I'm enrolled in data science with Power BI course at IvyProSchool. Today, we are going to dive into the world of exploratory data analysis or EDA. EDA is a crucial step in the data analysis process that helps us understand and gain insights from our data. So let's begin. What exactly is EDA? EDA is an approach to analyzing and visualizing data to uncover patterns, identify anomalies, and test hypotheses. EDA also helps us to understand the characteristics of our data before we move on to more advanced analysis and modeling. Now, you will think, why is EDA important? So, EDA will help us to understand the data. It will help us to explore our data set. It will help us to familiarize ourselves with the variables, their types, and distributions. Next is it will help us to identify data quality issues. Like if there is any data missing or if there are any outliers or inconsistency, then we can handle them properly. Next, it will help us to find patterns and relationships. EDA, it will also allows us to understand if there is any correlation, like if there is any trend or if there are clusters that we can find that we cannot find in our first glance. Next is EDA process. So the first step is data collection. In this, we obviously collect the data from various sources. It can be text, it could be like numbers, variables, it could be anything. Next step is data cleaning. Now, once we have got the data, in the real world, mostly data will be very dirty, very unclean. We will have to perform like various steps, like we have to remove duplicates, we have to if there is any inconsistency we have to handle that. So those steps come in data cleaning. Next is data exploration. So this is the heart of this process. In this process we use statistics, we use visualization, we use descriptive analysis to understand and explore our data. Next is feature engineering. Now, in this step, we create new variables or transform existing ones to enhance our understanding of the data or to improve the performance for machine learning models. Next is data visualization. Now, in this, we use plots like histograms, scatter plot, box plot. They help us to understand if there is any relationship. Uh, it also helps us to identify any outliers or understand distributions of variables. Now let's get our hands dirty and let's start coding. So I have downloaded this data set from Kaggle.com. This is a data set collected through a survey conducted with the university students to examine their current academic situation and mental health. So this has a few different columns like timestamp, basically when the entry was made. Uh, it has gender, like gender basically, age of the candidate, in which course they are enrolled in which year of the course they are in, CGPA, the range of CGPA, if they are married or not, they have depression or not, they have anxiety, panic attack, specialty, like if they have visited any like doctor or a specialist or not. So this is the data. Let's start. with the analysis now. First, we are importing few libraries, pandas, numpy, matplotlib, and c1. So these are the all the basic libraries that we will use in our analysis and EDA part. This matplotlib inline, this will help us to create or generate the uh, plots in the Jupyter file itself. So first step will be loading our data. That's the main step. I've created a original variable like original data. Now I have did pandas and I've read the CSV file. This is a location where my file is kept. So yeah, I loaded this file. Next, we what I did is I did a dot head. Now what dot head does is it will index wise it will give you the top certain number of rows. Like, by default, it will give you five number of rows, like from 0 to 4. You can see that. We can also give any number in that. Let's say I want only 3 rows. So what I can do is I did dot head 3 and just give me 3 rows. By default, it's 5, and we can give any number of we can like get any number of rows from this. Next step is data cleaning. Now, basically in data cleaning, we do is we rename the column heads. Like we can see in this, they are very big names. Like while doing analysis, this will be a hurdle. So we can rename the columns. We have to handle the missing data if there is any, and we have to also handle duplicates. Okay. So, first step, what we do is we do .info. So, what .info does is it will give you high level information about your data. So, we can see that our data has 101 entries, and these are all the column names. These are all non-null number of rows. It has non-null means like the row number of the rows where there is some value. It could be 0, 1, anything. But there should not be a null. There should be no, that the column should not be empty for that row. So if we analyze here, we can see that age has one missing value. Like age has 100 non-null count of rows, and every other column has 101 rows. So we will have to handle this one thing. Next, what I did is I did an unique. Now, what n unique does is it will count the unique number of like values for every column. Now, timestamp has 92 unique uh, values. Gender has two. Like that's obvious because we it could be male or female like in our data. So age has 7. We will have to look into this column once. What is the course? So course has 49 different unique values. This is a bit like I find it to be an anomaly. We will have to look into this part. Current year of study is also 7. Ideally, this is the data which was done for bachelors. So bachelor do not have 7 years. So this is also an anomaly. CGA part also it seems to be fine, but we can have a look on this column once. Marital status is yes or no. Depression is again yes no. So it has two again same for the rest 2 and 2 and 2. So let's start with the column wise unique values. So what I did is the original data. Now let me show you this thing. Now what I did is in the original data I pick a single column. So in this I have chosen what is the course. So in this if I do that, this will return me a series like a list of all the column, all the values. So this has 101 values in this. Now in that I have done unique. So it will give me all the unique values which this column has. So if we see like Islamic education BIT, now this engineering, and if you see, there's this engine. So I believe these both are the same. And then this is Islamic education, where E is small. Here, Islamic education and E is like capital. So this is sort of duplicates. So we will have to handle this once we do, like once we go ahead in the processing and data analysis process. Next, we have done for CGPA. Now in CGPA, you can see that this part is repeating, like 3.5 to 4, and here also 3.5 to 4. So the difference is there is one extra space in this. So we will have to handle this also. This also a duplicate. Current year of study, like this was 7 value. So as I said, like this seems to be an anomaly. So here year 1 is a small, y is small, and here y is capital. So these are also duplicates. We will handle this also once. Now in the age column, what we did is again we did a dot is na. Now what dot is na does is it will check for every row if the column is null or not, and this will return us a false or a true series. And in this false true false series, if I pass it to the original data once again, this will return me the single value where true, like where the age was missing. So this is how I got the missing value for age. If you can see, yeah, .na. So let me summarize till now. From above, we have summarized that we will have to rename the columns. Uh, we'll have to remove the timestamp because that column seems to be not usable for us for now. The age column has one missing value, so we can either we can either fill a mean of age, or we can remove that particular row because this is only one row, and the industrial standard is if we have 5%, like less than 5% data, we can remove if like there is some problem with that data. Next, course name needs some formatting. So like laws and law, like if we see laws and there should be a law somewhere here. You find it, yeah, law. So these are also the same thing. So it has duplicates. We have to remove duplicates. Current year also has duplicates. It has formatting issue. Year one and year one, these are like both the same. So we have to do something for that also. And CGPA column, like some in the CGPA column, some rows there are space, so that is also creating duplicates. So we will handle that. Now let's start with handling these all problems. What I have done is I have created a copy of the original data, so we can keep the original data intact. That's a good practice, and like personally, I like that. Uh, Now we have removed the drop, like we have used drop to remove the timestamp column. Now it has one argument which says access equals to 1. It means that I have to drop the column and not the row. 0 is row and 1 is column. And in place true means that we have to make the changes in this particular data set, and we don't have to create a new data set or a copy of data set with these changes. Now, ideally, this does not return us anything because in place true, it will do the changes in the background, and it will be done with it. So, just to verify that what we did that has been implemented, the I did dot head. So basically, like we can see that timestamp column has been removed. The timestamp column was here. Now we don't see any timestamp column. Now next part is renaming the column headings. Now here I am using the dot rename. This will rename all the values. That this will need a dictionary, and with that dictionary, it will change all the matching values. So here I've passed the columns. Like what we have done is that we want to change the columns, the column names, and not the values in the data set. By default, it will change the values in the data set and it won't touch the columns. So we have to specify that we need to change the columns. I've changed I've shortened the names. Choose gender. I've done gender, age. Like I've removed the small. I've done the small a and removed the capital A so that we can have the similarities like on the column names. Course name is course, current year is current year, CGPA is marital status and all, same thing. And again, I have done in place true so that we can make the changes in this dataset itself and did the dot head. Now we can see that the names have been changed. Till here, the name was very big names. Now the names has been changed and the data seems to be very clear now. So yeah. Now, next thing what we have done is I have removed the uh, NA, like the age column. Now, what drop NA does is this will drop any NA value. NA means not like null values. In place true again, so that data is changes are done in this. And now, see, because of in place true, this will not return us anything. So, I have what I've done is I've again did is NA on the data, and now I have done the sum of all the values. Now the thought sum returned us that there is no missing values now. So the is NA will be false, and false is always counted as zero. So sum will be zero. This helps us to understand that what we have done that's been implemented. Now we will handle the course format name. Now, course format, again, as I said, if we don't mention anything like column or anything, it will return sorry, it will replace the values in the data set. Now, we have passed a dictionary to this. I've created, like, I've listed out all the names, like all the problematic names, and the names we have to change it with. So engine will be engineering, small e engine will be engineering again, and so on and so forth. I've done all the things in place two again. So changes are done in this. And now, if we see if it take the unique for all the for the course column, now we can see that mostly there will be no uh, repetition or any duplicates. So yeah. Now we will handle the current year. Again, same thing, replace the small y here with the capital Y here and in place true, give me the unique so that we can, check that the changes are done or not. Changes are done. We can see this is the only columns, like all the only values now. Now the last part is removing the space that we found in here. One sec. Here, the space. Now, what I have done is I have used the lambda function and did a apply on this working data set. Now, what dot apply does is this will apply whatever function we will provide to the apply function. It will apply that function to every row of the data set. So I have chosen the CGPA specific column data and I've applied to like x dot strip. Strip will basically remove any spaces from the end of the string. So this has removed the spaces, and again we can see that now there is only one 3.5 to 4 CGPA. That's it for handling the the data set for correcting and doing some data cleaning, as we've discussed on the previous slide. Next part is now doing some basic descriptive analysis and visualizing the changes. So in this part, what we will do is we will try to see distributions for all the columns, and we'll also try to do univariate and bivariate analysis. Univariate is doing analysis on only one column. Bivariate is doing analysis on two columns. So let's start with doing gender distribution. Uh, so let me just create a new cell, and I will show you how I've reached to all these formulas. So I started with a single column, that is gender. On gender, I did value counts. Value count will return us the number of uh, count, like the number of count for each value, for each unique value. So gender has female and male, two different values. Female has 75 and male are 25. So this is our base data on which we will create this pie chart. Um, so here I have mentioned the same thing till here. Now the next thing that I've mentioned is labels. So labels are these two, or the value, the unique value which is present in our data. So from this value count, we can do index, and we can get the in the list of those two particular values. So this is the label, female and male. Next, I have done is auto PCT. Auto PCT is percentage for both female and male. So this is the format for PCT. Next, I've done is explode. So basically, this style is a bit far away from the other one. And label distance means where exactly do I need this female and male to be present. So I want it to be in between of these two tiles. So that's it for the pie chart. From this, we can analyze that females are 75% and males are 25. So this will create some biasness in our resulting analysis. Next part is for age. So in the same thing, I have provided X. X is the this 18, 19, 20, the age exact number. So working data age column, on age column I did values. So that gave me 18, 90 and 20. Let me show you once. So from the value count, this is our base data, and in that I did index. So index A will be our x-axis. So this is the list for x-axis, and if I do values, this will give me the value for those indexes. So that's it. That's how we created this bar chart. I also did the same thing for current year. So for the instead of age, we have current year, and the rest are same. So from these two charts, we can analyze that majority students are like 80, 90. So majority are college freshmen. That would also create some biasness in our data. So yeah, that's it. Next, we will create a very big chart. This is year-wise, how many, like which all like how many candidates enrolled in which all courses. So this seems to be very complex, but this is very simple. Let me show you how I got to this very big statement. So I started with the working dataset current year, and I checked if that dataset is of year one or not. Let me mention one year one. This returned a list of true false. So just give me a sec. Yeah. So I will again pass this series to working data. This will give me all the data where current year is year one. Now in this, I have to group this whole data by course name. So what I will do is I will do group by course, and in this group I will do count. This again returned a data frame, and now we can see the data is grouped, and we can see that this ALA has only one row, BCS has 10, similarly for all the courses. Now we can select a single column in this, that's pick gender, and do count again. Now we have a sort of a series. Now ALA has one, so all the data are same. Just now we can see we are able to see for gender specifically. It doesn't make any difference. We could have chosen any column. Values will be same for all the columns. Now on this count, I don't want count. I want value count. So value count. No, no, I'm sorry. On this, I want yeah. So I want count only. I'm sorry. On this, we need count, and on count, I need that count to be sorted. So I will do sort values. What sort value will do is it will sort the like this series on the basis of these 1, 1, 2, 2, 3, 3 value. And now I want it to be in descending order. So I will pass ascending to be false. I'm sorry. Please excuse my keyboard is not working properly. So now I have this series and the data is in descending order. In on that I need a head. So I have now top five values. Then okay, for the rest data like index and values, we need x and y's. So that will be index and values. So I've explained you this part. Now let me show you. Now let me brief you how, like why I've created this loop and everything. So I've created a figure. Now this figure has four different axes, two rows and two columns. You can see two rows, two columns. Okay, the figure size is 12, right? So it's a sort of a squarish figure. Then I set the super title. Super title is this title, like the title of the figure, the whole figure. Next, I created a list of all the current year. So again, this is very simple. I explained like working data. Then I chose the current year, took a unique of all the values, then make that in a list. Now, so I can show you also one so that you don't confuse. It's very simple. Year one, year two, year three, year four. That's it. Then I've created two loops. One loop is to run for the two row, and for two columns. These two columns. Okay. Now, in this, I've replaced this year one with the element of current year list, and I did a counter plus one. So every time this loop runs, this counter will increase by one, and for and this current year list will have like first it will have year one, then year two, year three, and year four. So yeah, that's it. And then after like fetching the value of x and y, created a bar chart, and for that bar chart, I just set a title. title is current year, like the value for on which we are running, like the year one, year two, year three, and all those things. These are cosmetic things. So just to make our figure something attractive, some interesting. And the last part is rotated the value, the index here. So because it will overlap to the another bar, like to another tile. So that's why I just rotated this 40 degree, 45 degrees, sorry, 20 degree. So yeah, that's it. That's a very big chart in very simple terms. From this, we can analyze that majorly all the students are of engineering and the computer field, like engineering, Bachelor of Computer Science, IT, same here, engineering, BCS. Here it's a KOE, also something, I don't know, but this is some course. So after that, like instead of doing it year wise, I've just also created the whole bar chart, like for all years cumulatively. So yeah, here we can like, analyze properly that majorly students are of engineering, then BCS, then IT. So this will also create some sort of biasness in our data. Um, so yeah, now we will start with using the SNS library. SNS is Seaborn. You saw that this is very complex, a bit complex uh, code. You have to write we have to write some repetitively and everything. So here SNS it gives us some like it gives us like simplicity. So on while using SNS, we will do is we will create a category plot. So in that, what we will analyze is for all the current year students, year one, year two, year three, and year four, just like, do they have anxiety or not? So data is our whole working data set. X will be current year. So X is current year. Hue is what we have to analyze, like yes or no, the differentiation, and the kind is count. So like it will return us count for all the different yes and no's for every year, year one, year two, year three, and year four. So that's it. Again, we have done some cosmetic things. Set the title. X label is current year, and Y label is count of students. So this from this we can analyze that majority of students they do not have anxiety. So yeah, I've done the same thing for depression. Now everything is same, just hue is depression. Another thing is for panic attack, same thing. From this, we can also analyze that the orange part is no, so majority students they don't have depression. From this, we can analyze that again orange part is no, so many like all like majority of students they do not have any panic attack. Now I did the analysis for for the age. Like, do they have anxiety for anxiety, panic attack, and depression for different ages? So we can say that majority of students they do not have anxiety. Like if this shows panic attack, they don't have any panic attack. Um, this shows anxiety. So majority students do not have anxiety. Just 18 years old, they have some anxiety, but that also goes downhill from there. Now, majority students they don't have any depression also. So yeah, that's our analysis from these three charts. Okay, so after that, what we will try to do is we will try to analyze between two different columns. So what we'll try to analyze here is the people who have depression. Do they have anxiety or not? So okay, so let me show you how I reached to this very big statement. I started with working data depression as yes or no. So I will copy this, paste here. So this has returned me all the columns where has depression is yes. Now here I will try to pick up has anxiety. So people now I've got the value or yes and no. So in this I will do value count. Now we can see people who have depression in from that 18 people have anxiety and 17 do not have any anxiety. So I have done this same thing for people for not having any depression. Same thing. Now from that 49 people who do not have any depression, they don't have any anxiety, and only 16 people have anxiety who do not have any depression. So I've done this thing for all, like for all the, I did all the probab like for anxiety and depression, for depression and panic attack, and for panic attack and anxiety. So let's see. For first, let's see for this a bar chart. So I used again a cat plot, category plot. Data is our main working data. X will be do they have depression or not, and U, that's the differentiation, that will be people who have anxiety or not. Count again, like we need the kind to be count. So people who have depression, they have equal probability of having and not having anxiety. And people who do not have depression, they have very high chance of not having any anxiety and very less chance of having anxiety. Yeah. So that's what I've written in the analysis part. Equal likelihood of experiencing and not experiencing any anxiety. Students with depression have lower probability of having anxiety, and the majority do not show any symptom for both. Now, I did the same thing for having panic attack and having anxiety. So, 20 people who have anxiety, they do not have any depression, and sorry, have do not have any anxiety, and only 13 people have panic attack and anxieties. And people who do not have any panic attack, they don't have any anxiety also, and very less people, like 21, they have anxiety. So again, very likelihood of not having both panic attack and anxiety, but there is slightly more than 50% chance of having of not having sorry of not having any panic attack if you have any anxiety. And yeah, majority do not show anything. So that's what I've written in analysis. Students who are experiencing panic attack have slightly higher chance of having anxieties. Yeah, and students who do not have any panic attack, very less chance of having anxiety. Majority show do not know anxiety or panic attacks. So yeah, and next I've done is depression and panic attack. Same thing. If they have depression, 90 do not have any panic attack, and 17 have panic attacks. If they do not have any depression, only 49 do not have. Yeah, so like a very high number do not have any panic attacks also, and 16 have panic attacks. So again, equal likelihood of having and not having anxiety if you have depression, and very high chance of not having both panic attacks and anxiety. Now, for the last analysis, what we will do is we will try to understand people who have like either anxiety or depression or panic attack. Do they visit any specialist or like a doctor or not? So again, I've created a figure for one row and three columns, given it a super title: anxiety, depression, panic attack versus like doctor visits. Created a column list of three columns: anxiety, depression, and panic attack. Now here, what I've done is like I've iterated through this column list, and for having for the all the people who are having anxiety, I did yes and checked if they have visited a specialist or not. Let me show you one example. So I'm copying this whole thing, paste. Let me replace this with the has anxiety. Sorry, has anxiety. Yes. So this will give me the list, like a whole data set of people who have anxiety. From this, I have to pick visited. Let me just copy it from here. Visited specialist, and I will do value counts for yes and no. So people who have anxiety, like yes, only 3 out of 34 people they visited a specialist, and 31, like majority, did not go to any specialist. So I've did the same thing for all the three, for all, sorry, for all the other two columns also. Has depression and has panic attack. X has yes or no, the indexes, and Y has the value counts. I've created a bar chart and set the label like for the respective column name. So we can we can see this one whole chart. So like like all the people who are either going from anxiety, depression, or panic attack, majority are not going to a specialist. So this can be our final analysis that that we can present to our to our seniors and to the stakeholders, that in the university they can like either have more doctors. We can increase awareness for all these anxiety, depression, and panic attacks. So this can be our final analysis, and with this we have completed our EDA part. So let's go to a conclusion now. So we can conclude that EDA is very powerful tool that allows us to uncover hidden patterns, identify anomalies, and gain insights from our data. It also helps us in making better decisions, like build accurate models and derive meaningful conclusion from our data. I hope this introduction to EDA has sparked your curiosity and motivated you to explore the exciting field of data analysis further. Don't be afraid to dive in and let the data guide you. Till then, keep exploring, keep analyzing, and always remember that data has a story to tell. Happy analyzing, everyone. Have a nice day.